Hello, and welcome to Chuck, Cooper, and Akshat's mathematics presentation on finding the first and second derivatives of a function and creating a graph from it. We chose problem number 5.
So the original function was 2x squared minus 3x over x minus 2, and to take the first derivative of that, we had to use the quotient rule, which simplifies out to this. And to do that, we had to do low d high minus high d low all over low squared, which simplified to this function. And then I factored that to be able to get the zeros and the undefined. So the numerator tells you your zeros, so we found that the derivative would equal 0 at 1 and 3 and would be undefined at 2. From there we took the sign chart, choosing values between 1, 3, and 2, and we found that it was positive when it was less than 1, negative from 1 to 3, and then positive again from 3 up. And so from this we were able to determine that it was a max at x equals 1, and this is finding the y coordinate for that point, which also was 1, and then a min at x equals 3, and got a y coordinate of 9. And then we were able to determine that it's increasing from negative infinity to 1 and from 3 to infinity. And we found that it was decreasing from 1 to 2, union 2 to 3, based on the positive and negative portions of the derivative.
Using the quotient rule, we determined the second derivative, which we then simplified. We determined that the second derivative is undefined at x equals 2 because both the numerator and the denominator equals 0 when x equals 2. Then we made a sign chart with 2 in the middle, and we determined that below that it is concave down, and above that the function is concave up. Since the first one is concave down and the second one is concave up, it means that between them x equals 2 is a point of inflection.
From this data, we were able to put together a graph using the sign charts of the first and second derivative, because we now have the knowledge of where it is increasing, decreasing, concave up, concave down, where there's an asymptote, and all the critical points. So from negative infinity to 1, we made our graph constantly increasing until it reached what we found as a maximum at the point 1, 1. Followed by an asymptote at x equals 2, which is our point of inflection, as we discovered from the second derivative. And after x equals 2, we have it coming back down from the top of the asymptote with a minimum at 3, 9, and then it continues constantly increasing according to our sign chart of the first derivative from 3 to infinity. The function, however, is decreasing from 1 to 2 and from 2 to 3, not including 2, where it is discontinuous. We were able to determine the concavity based on our second derivative chart, which is how we got the curves correct in our graph. It is concave down from negative infinity to 2, and concave up from 2 to infinity.